today we got the STM32MP135 development kit, and today we will prepare the U-boot to run our own applications written in C or assembler, so basically bare metal applications, and we will run it from the micro SD card, and right there we will create a FAT32 partition, and we can just simply put the files of the programs right there and get them running. So let's take a look at an example. So we got the device connected to the debug port of the UART through the ST-Link. We got the switch positions in the boot from SD card. So let's reset it, and we got a message from the U-boot. The auto boot is set to 5 seconds, and we got our application loaded to the address we put it in the configuration, and it just prints a charter. So now let's take a look at the U-boot. Okay, so let's go to the location where we got the U-boot. For my example, it's this. So now I'm running a command prompt to go to that folder, and now let's invoke the Linux, in this case Ubuntu LTS, and now let's make a cleanup first. So make mr proper Okay, so that's done. So now let's take a look at the config files that we got already prepared. So let's search for the STM config file. So this is the original, I rename it, and in this config I just changed the command prompt to something like this. And now let's go ahead and load this config. So okay, so it created a file.config in the main folder of the U-boot. You can go ahead and take a look at it. So in this file you got all the options you have configured. You can also modify this by the menu config, or you can just simply change it right here. So in my case, I need to change the boot command. Right here. So from run boot cmd STM32MP to something like loading a FAT partition, and from there a file with our program. So in this case it would look something like this. So we got here two commands that we need to execute, and it's fatload mmc. So 0 is the instance for the SD card, so the instance 0, and here we select the partition which we want to use. So in this video I will create a FAT32 partition on the number 6, and we will load from there a main.bin file to RAM address like this. And after this command, the next command is to run the program which is located in this section of the RAM. So this is pretty much it. So we can just do something like changing this one up. Okay. So now we can just go ahead and build the bootloader which we got. We can also do something like make menu config, and we can just load this right here. The config we just have modified, and you can do the same right here somewhere. So you can do both ways. Okay, we got now the config ready. Let's just type in make. And this usually takes quite a while. There are a lot of files. And as you can see, there are quite a lot of files which are compiled by the PC side compiler. So the host GCC and so on. And now the ARM compiler, so the GNU GCC, making the U-boot. And also don't forget to activate the FAT partition in the bootloader configuration. The config file will be in the link in the description of the video, so don't worry about it. You can take a look at it. Okay, so now we got the U-boot linking and we got the objects for the bootloader, I mean the U-boot. So now let's take a look at two files. So the U-boot node database and the U-boot database. So we want those two files to be put into our SDK of the STM32MP. So I got it located in the developer package in here, and I created a ucreate folder, and in this folder I got files that have the tpager, pageable, header. Those files are needed to put in together with the U-boot in order for the TFA to read it correctly. If you don't put it with those optional files, it will just simply tell you it failed to load images. So keep that in mind. Those files you can find in the images. So right here you got the header, pageable, pager. So those files which you need to add, and you have to remember to add the correct board into it. Okay, so now let's go back to the developer package. Okay, and now let's close up the command window, and now let's head into this directory. Okay, so now let's get the environment loaded by copying this name and making it a source. Okay, so now let's go to the folder we got. So and now as we got those files, we will create a FIP package. So firmware in package. Let's rename the old one. And I've got a script to copy to generate this file. And let's put it in. And let's name it ufip1.bin, and let's create it. Okay, so we got this file, and we need to copy it into the images folder. And let's put it right here. So I got the old one now renamed, and I'm putting the new one in. Okay, fine. So we got this. The next step, in order to make the partitions in Windows, is to use the flash layout provided by the STM. So let's take a look at op3, and right here is the original one. So right here, what you would like to change is to change this FIP into our own FIP. So you can copy this file. I created a file like this, and right here we got our own FIP file to download. Okay, so now let's go ahead and First, let's connect to the port. So let's plug in the device. Okay. Okay, and now let's set the pins of the boot pins, into the position of the USB bootloader. Reset the board, and now let's just refresh. We got the device. Okay, and let's open up our file. So always check if this is correct. So the folder of the files you got, download, and what we don't want to download to the SD card is the user FS, root FS, vendor FS, and those are also not needed because they just erase things. So okay, the boot FS is needed in order to make a FAT32 partition from Windows, the easy way. So now let's just simply download the program. So the board is right here, maybe something like this. And now let's click download. So it's downloading. And as it does so, it also indicates on the screen. So the file of the system, so bootfs, is a little bit big, but after the downloading you can just simply format it and it becomes the full size of the SD card. So you don't have to download a image which is the size of a SD card, for example. Probably for future use, the system can be replaced by some other smaller file that just creates the partition. But okay, we got this downloaded. Okay, so now let's simply take out the SD card and put it into the Windows computer. And now we got multiple windows popping up that indicate that they can't read the SD card. Okay, so now let's open up the file manager, and the last partition right here This is the bootfs system. So let's simply just right click and format. Okay, so we got this. So now we need to put a bare metal application, and for this you can use some available examples on the internet. I got this repository downloaded, and let's just take this example. So let's take a look at the function we got here. So I uncommented something like this, because it had some problems with working. However, this example works like it prints a charter and waits a little few milliseconds. Okay, so as we got this example, we can also build it. So let's just open up a new command prompt, go to this folder, clean up the solution and build it. Okay, so we got the main binary file, and let's go ahead and copy it into the partition of the micro SD card. So it looks like this. So now let's take out the micro SD card. Let's open up the terminal. So in the terminal we got the same as here. So now let's put in the micro SD card to the device and set the pins to boot from the micro SD card. Okay, and now let's take a reset. So we got the auto boot loading, and the example is printing the charter we just put into the program. There is one thing about the U-boot, and that is it invokes the independent watchdog in the microprocessor, and you have to see right here, it just reset because the watchdog wasn't disabled or fed. So keep in mind to disable the watchdog or just feed it in your own program so it doesn't reboot every 32 seconds or so. But yeah, this makes running your programs from the SD card. So thanks for watching, hope you find it useful, and see you in the next one.